Hi everyone, this is Sandeep. You are watching Samyans Academy, and today we are going to discuss about exploring the magnets, 6th class science from curiosity. Introduction. Exploring the fascinating world of the magnetic and non-magnetic materials and learn how to use the magnet to find the directions. So let us start now. Yes, introduction to a magnet. Here we have the two types of magnets, natural magnets and artificial magnets. So what is natural magnets? Natural magnets means so magnets can be found naturally such as iodine stones which have been used for the centuries. Okay, previously our ancestors used only like these magnets only, and this type of magnets we called as iodine stones. Now here we have artificial magnets. Artificial magnets are different shapes are there. So one of these Harshof's magnet, bar magnet, and U-shaped magnet, ring magnet. And this magnet can also be artificially created from the materials like iron and other materials. And this magnet is has many applications every day in our life. So magnets are found in many common items like pencils, boxes, toys, and school supplies. Okay. So next one, magnetic versus non-magnetic materials. Now based on attracting power, so this magnetic material classified into two types, magnetic materials and non-magnetic materials. So magnetic materials means like iron, nickel and cobalt are attracted to the magnets. Iron, nickel, cobalt, and one more is there, steel also there. Okay, these are the magnetic materials which are attracted by the magnets. Okay, and now what is non-magnetic material? Non-magnetic materials are like wood, plastic, rubber and glass which are not attracted by the magnets. Okay, so what are the magnetic materials? The materials which are attracted by the magnet we called as magnetic materials. What are the examples for the magnetic materials? Those are iron, nickel, cobalt, and one more is there, steel is there. Then how to remember this? I means iron. C, I can. Now C, that is steel, and Ni, Nick. You remember like this, my dear children. You remember like this. I means what I indicates here. I indicates iron. What can indicates? This is indicates cobalt, and C indicates steel. Okay, and Nic, Nick indicates nickel. Okay, these are the magnetic materials. To remember this, you just remember this code. I can see Nick. I means iron. C means can means cobalt, okay, and C means steel and Nic means nickel, and these are the magnetic materials. These all are metals. Okay, and these metals are attracted by magnets, so we called as magnetic materials. Yes or no? Now we have non-magnetic metals also there like copper, gold, aluminum. These are the non-magnetic materials and which are in metal form. All metals do not attracted by the magnet. Only iron, nickel, cobalt, steel, some other materials only attracted by the magnet. So those materials which are attracted by the magnet we called as magnetic material. Those which are not attracted by the magnet called as non-magnetic material. Yes or no? Now you see what are the non-magnetic materials. For examples, we have here wood, plastic, rubber and glass. These are the are not attracted to the magnets are called as non-magnetic materials. Everyday magnetic uses. So magnets have many applications in everyday life, such in we can use in refrigerators and we can use in speakers and we are using in the toys, we are using in tape recorders. So in many applications we are using now these magnets, and for electric motors, for generators, and everywhere we are using the magnet. So magnets has so many applications in everyday life. Okay, now you see understanding magnetic poles. Now let us see children, and every magnet has two poles. One is, what is that? One is north pole and other one is south pole. Okay, every magnet has how many poles? Ranks, every magnet has only two poles, and one is north pole and other one is south pole. The magnetic force is strongest at these poles. Okay, so where we can see maximum maximum strongest force. Yes, where we can see at the pole. Here we can see maximum. Now you see, so most of the iron particles, when you sprinkle the iron filings on this magnet, so most of the iron filings are attracted at the poles. Why? Because at the poles the magnetic field strength is more compared to the middle. Okay, now you see every magnet has two poles. What are the two poles? North pole and south pole. And the magnetic force is strongest at this pole. If you were to sprinkle iron filings around a bar magnet, you would notice that the filings gather more densely at the ends of the magnet, indicating the location of the pole. Okay, when you sprinkle the iron filings around the magnet, so most of the iron filings are attracted towards the pole. Why? Because at the pole the magnetic strength is more. Okay, compared with the middle part, that at the pole here, this is the north pole, this red color we call as north pole, and that this is the north pole, and this one is south pole. Okay, this red color indicates north pole, blue color indicates south pole. At this pole we can see many iron particles are there. Okay, and which are attracted at poles. Why these particles are attracting at poles? Why? Because here the magnetic force is strongest at this pole. If you are to sprinkle iron filings around a magnet, so we can notice that filings gather more densely at the ends of the magnet. So where we can see the iron filings? At the ends of the magnet. Why? Because at the ends of the magnet the field strength is more. Yes or no? Now when you compare with the middle part, so here we have very little amount of iron filings are there compared with the and this pole region. Here you see, here we have many iron particles are there. In middle there are only few particles are attracted. So in the middle of the magnet, so there is a weak magnetic force is there. At the end of the magnet, that poles, at the poles the magnetic field strength is more. Hence here and also we call it the magnetic force is strongest at these poles. Yes or no? Okay, so now you see why one pole is impossible. Okay, when you break magnet, many times like this, and north and south, when you break it here, listen here, and this magnet has how many poles now? Everyone please look at here. This magnet has how many poles? North pole and south pole. Yeah, this is, here we have north pole and here we have south pole. When you break the magnet here, again what happens? This magnet again split into two poles, and this side you will get south pole and this side you will get the north pole. So now you see here, even if you break the magnet into smaller pieces like this, each piece will still have a both north pole and south pole. Okay, these are the inseparable poles. A single north pole or south pole cannot exist in its own. The pole always comes in a pair. Remember, the pole always comes in a pair. If you break the magnet, again this magnet, when you break the magnet into again two smaller pieces or many pieces, and then each piece will have again both north pole and south pole, and these poles we cannot separate. These exist in pair. Okay, and fundamental properties, the inability to isolate a single magnetic pole is a fundamental property of a magnet. Okay, so why one pole is impossible? So why one is pole is one is impossible means, if you break magnet into any pieces or any smaller pieces, each piece again we have a north pole and a south pole, and we cannot separate this north pole south pole, and these poles always comes in pairs. Yes or no? Okay, now move on to the next one. Yeah, finding directions with magnets. Here we have two types of magnets are there: freely suspended magnet and the magnetic compass. So take one stand like this. Okay, so to this just you turn with one magnet here like this. Let us say this is a magnet. Okay, and this will show two directions. One is north pole direction and other one is south pole direction. So like this, when your magnet is freely suspended on a stand like this, okay, so this is the stand, so this is a magnet. So when you suspend the magnet like this, now you see it will always align itself with the earth's magnetic field pointing north and south. So this property has been used by sailors and travelers for many years to find the direction. Okay, when you hang the magnet, so this magnet is itself, it shows the direction of north and south direction. Okay, and when you hang the magnet and just you twist the magnet and you observe the magnet, after some time it will show the north pole, and north pole indicates north direction and south pole indicates south direction. Why this north pole attracted towards the north direction? Why? Because our earth, so for example, this is a north pole. Everyone please look at it. This is a north pole and this is the south pole. and our earth has also two poles. Our earth also acts as a magnetic giant. Okay, and it exists south pole and north pole. Now when you hang the magnet like this north pole is attracted towards the south pole of the earth, and south pole of the magnet is attracted towards the north pole of the earth. So in this way the magnet align itself in the north south direction, and this property we are using in sailors, and previously it was used by sailors and travelers for many years to find the direction. Now we are using the magnetic compass. Okay, so this magnetic compass is a device that uses the earth's magnetic field and freely suspended magnet to determine cardinal direction. So it is a crucial navigation tool that has been used for centuries. Okay, now we are to find the directions we are using now magnetic compass. Okay, so let us see what is magnetic compass. Now you see, before going to magnetic compass, then how that magnet works, the suspended magnet, how it will work. Now you see, when you suspend the magnet, so you take a bar magnet. So like this you take a bar magnet. Okay, so this bar magnet has two poles. What are those? North pole and south pole. North pole and south pole. Now, so what you have to do now? So take a bar magnet and suspended it from a thread. So just you tied one thread. So just by using the stand, so let us say this is the stand. Okay, so like this you hang it, right? So take a bar magnet and suspend it from a thread, ensuring it can rotate freely. Okay, so it has to be rotate freely. Align to north south. The magnet will naturally align itself in the north south direction. So rotate and release. If you want to check again you just you tilt like this, it will get rotate, and you release. After sometimes you observe that if you rotate the magnet and let it go, it will again come to rest. It will again come to rest, and this pointing towards the north and south direction. Now the ability the ability of a freely suspended magnet to always align itself in the north-south direction is used to determine directions and form the basis of magnetic compass. Okay, by using this concept, and we made one magnetic compass. Magnetic compass works based on this principle only. Okay, so in this experiment what we are doing, we have taken one magnet and we hang it from by thread and ensuring it can freely rotate. After some time the magnet will naturally align itself in the north south direction. So this direction indicates the our north direction, and this indicates south direction. If you want to check again, so then what you have to do now, just you rotate like this, you rotate the magnet and let it go. So it will again come to rest, and it will again shows the same pole, north to north direction, south pole is shows the south direction only. It is again come to rest and pointing north to south direction. The ability of freely suspended magnet to always align itself in the north south direction, and which is used to determine the directions and form the basis of magnetic compass. And based on this rule only, and we made magnetic compass. Okay, so now you see what is magnetic compass. Let us start. Let us see now. Yeah, this is about magnetic compass. Now you see here we have given the magnetic compass. A magnetic compass contains a needle shaped magnet that can rotate freely, and this needle always points in the north south direction, helping people find their way. Now you see, and this is a magnetic compass. On it has one magnetic needle, and you see this it will always shows the north direction and the south direction, and which is used by many sailors to find the directions. Okay, then how it will work, we let us see now. Now you see, using a magnetic compass, what you have to do, so just to placing the compass, place the compass where you want to determine the direction. Suppose I want to check the direction here, so I place the magnetic compass here, right? So now waiting for alignment. Here we have one magnet, so this is, now you see here we have the one magnetic needle. Are you able to observe this magnetic needle, everyone? Can you observe this magnetic needle we have here? Yes. Yo, this is the magnetic needle, right? So this is a magnetic needle. You see, this is a magnetic needle, and here also it indicates like this. Now you see, this is a magnetic needle. Okay, You observe this. After a short while, the needle will settle in the north south in direction. Then, so if it is not in north south, just you rotate this dial so that it has to match north. This pointer match with the north, and the other side match with the south. Okay, just you have to rotate the dial like this, and this pin is stable here only. It won't move. It won't move. We have to move this dial. This dial you have to move so that this N will match with this pointer. This S will match with here. Okay, now this pointer indicates the north direction and the other side indicates the south direction. So gently rotate the compass box so until the north and south marking on the dial, so it matches the needle's position. So we are matching the needle positions to the north and south direction. So this backside dial we can rotate, but this pin won't rotate. It always it always shows only north and south directions only. Okay, so when you rotate gently, so this dial and backside position of this dial, when you gently rotate the compass backs until the north and south marking on the dial, so match this needle position. So suppose let us assume that our north position is here. So this north position is here, this south position is on this dial, but pin is showing this direction, north is. So what you have to do, so you have to just rotate like this. So north has to come here, so north has to come here, south will go to here. Like that you have to gently rotate. This north has to come here and south has to go there, and this pin always shows the north south direction only. This pointer indicates north direction, the other side indicates south direction. So in this way you have to use the magnetic compass. So while magnetic compass, what you have to do, what is the first step? We have to place the magnets where we have to find the directions. Okay, so where we want to determine the direction, where you have to place the compass, and you have to wait for alignment. So it will take a while, it a short while, the needle will settle in north south direction. Okay, this needle will settle in north south direction, but PS or N is here on the dial. So what you have to do, and you have to rotate like this. Gently you have to rotate the compass box, so until that, so the north and south marking on the dial match this needle position. Okay, finally from this we came to know where is the north, where is the south. Okay, now next one, structure of a magnet. Now you see, a magnetic compass is typically small circular box with a clear cover. Inside the box there is a needle shaped magnet placed on a pin that stands at the bottom, and this needle is balanced on the pin in such a way that it can easily rotate or move freely around this point. The end of the needle that points towards the north is usually pointed red. Beneath the needle there is a dial with direction marked on it. Now you see, this is a magnetic compass, right? This is a magnetic compass, and it, what is a, it is typically a small circular box. Just a minute. Okay, so now it is a small circular box with clear cover. Inside the box there is a needle shaped magnet. Okay, inside the box here we have, so this is a needle shaped magnet. Have you seen this side needle shaped magnet here? So here we can see this is a needle shaped magnet. Okay, and this is a needle shaped magnet, and you see, and this point always shows north direction and this point always shows south direction. Okay, so there is a needle shaped magnet placed on a pin. So where we have placed this needle shaped magnet, the red color pointer is indicates north direction, other side indicates south direction. This pointer, this magnet shaped pointer needle placed on a pin. So this that stands at the bottom, and this needle is balanced on the pin in such a way that it can easily rotate or move freely around this point. Okay, so because of free rotation it can freely rotate, and always it align itself in this direction of north and south direction. Okay, the end of the needle that points towards the north is usually painted red. Now you see, and this direction, this is painted with the red color, this pointer which is painted with the red color, which is showing with the north direction, and this is showing with other side we showed with south direction. Okay, the end of the needle that points towards the north is painted red. Beneath the needle there is a dial with the direction marked on it. So you, when you see the beneath of the needle, Okay, below of this pointer we can see these directions: east, north, west, and south. So you have to rotate this magnet gently so that this north has to come below the red color pointer, south will come here. Okay, so in this way you have to use a magnet. Now, making a simple compacts. Okay, so how will you make the simple compacts? So you take one magnetized needle and stoke a sewing needle with a magnet, prepared a cork. Now you see, just how will you take the magnetized needle? Let us see. You take one magnetic needle like this. Let us assume this is a one needle. Okay, so this is a needle, and you take one bar magnet. Okay, so north to south. Okay, just you lift this bar magnet and just you rub it for some time. Again you lift, again from here, again you place here, again you rub it here. Okay, so which direction you have to show here? North direction. End of the north bar magnet you take by placing this here. Just you rub it like this. Many times you rub it like this. Just you lift it, again you place it. Just you lift it, again you place it. Just rub it, lift it, again you place it. Many times when you do like this, the needle will get magnetized. Okay, and for needle this magnetized, afterwards what you have to do? Just you insert one cork here. Just you insert one cork. Cork means a plastic ball, or you can take any plastic material which is in the ball shape. So let us say you insert this you insert here to this cork ball. Afterwards push the needle through a cork. You just push this needle through a cork. Then you take the bowl, you place it in the bowl. So you take this bowl like this, you place this bowl. Okay, so now this is a bowl having some water. Okay, like this, having it will have some water, and place the cork in a bowl of a water. Then observe what will happen here. You can make a simple compacts at home using a sewing needle, a cork, and a bowl of water. The needle will rotate and align itself in the north-south direction, and this will get rotate. Okay, and this pointer shows north direction. This end of the needle shows south direction, and this simple needle also we can use as compass. Okay, then how it will rotate? The needle will rotate and align itself in the north-south direction, similar to the ancient Indian navigation tool called Matsya Yantra. Also work based on this principle only. Okay, so what we are doing here? So we magnetize the needle by rubbing so many times. By end of the north pole of the magnet we are rubbing like this. Then the needle get magnetized. Afterwards what you have to do? Just you push this needle on a cork ball. Okay, so then this setup you placed in the bowl containing the water. So in this water it will freely rotate and it align itself in the direction. It will show the, this pointer shows the north direction, and this end of this point end of the needle shows the south direction. Then how it will rotate? It align itself in the north south direction, similar to the ancient Indian navigation, which is we called as Matsya Yantra. Is it clear everyone? Okay, so in this way we have to make the simple compass. Now you see ancient Indian navigation. So ancient our ancestors used to find the direction, they used your Matsya Yantra. Okay, so what is Matsya Yantra? Matsya Yantra was an ancient Indian navigation tool and consisting of a magnetized iron fish that floated in oil to find direction. Okay, then this Matsya Yantra, how it will, the shape of the needle, they made like a fish. Okay, let us see, let us assume this is like fish, right? So they will make like fish. Okay, and it has some magnetic needle. Okay, which is placed in oil. This Matsya Yantra placed in oil. Okay, which is placed in oil. Okay, it is like a fish shape material, fish shape needle, and the fish shape magnetic needle. Okay, and this side indicates north direction and this side indicates south direction. So why we call this as a Matsya Yantra? Why? Because Matsya means fish and it look like as a fish shape. Okay, consisting of magnetized iron fish and that floated in oil to find the directions. Sea navigation, and this device helped Indian sailors navigate the seas long before the modern magnetic compass was widely used. Okay, and sea navigation, it is used for the direction for sailors. And before discover this magnetic compass, they use this sea navigation to find the directions. Now, historical significance. The Matsya Yantra demonstrates India's early understanding and application of magnetism for practical purpose. Our ancestors already it is used. Matsya Yantra used as a, now we are in modern days we are using compass to find the direction. Our ancestors already they used what they used, Matsya Yantra. That means it indicates that they already know about this magnetism and they understanding the application of magnetism and also they use it for the practical purpose only. Okay, now come to here. Comparison freely suspended magnet versus magnetic compass. Okay. Freely suspended magnet, it hangs still unless you move it. And when you do, it takes some time to settle back into the north-south direction. Okay. By using the bar magnet, if you by using the suspended bar magnet, if you try to find out the direction means, it will you have to hang it and you have to wait for some time. So it will take some time to settle to show the north-south direction. But whereas in the magnetic compass, the needle in the compass moves quickly and smoothly, and also it points to north and making it easy to find your direction in a short time. Okay, and when you use the magnetic compass, within the short while you will find the north south direction very easily, right? Whereas in the case of magnet, suspended magnet, it will take some time to find the directions. Okay, now come to the next one is attractions and repulsion forces of the magnets. Magnets can exert forces on each other. Already you know that if you take the two magnets nearer to each other, so north and south pole, they attract each other. And when you reverse the pole and you when you try to bring the north to north, it will repel. When you bring the south to south also, it will repel. Means like poles repels and unlike poles attracted in nature. Okay, north south poles are attracted in nature. North to north, south to south, it will repel. Now come to the next one. Now you see, so opposite poles attract. So when you bring the magnets like this, so north to south, this north pole south pole attract in nature. Okay, when you bring like this north to north, it will repel, and when you bring south to south also, it will repel. Means when opposite poles of two magnets are brought close, they attract each other. Like poles repel. When like poles are brought close, they repel each other. Two opposite poles of magnet attract each other. Two same poles of the magnet repel each other. Just you remember like this. North to north repel, repulsions will take place, and south to south also repulsion takes place. When you bring the north pole of one magnet to the south pole of the another magnet, it will get attacked. Okay, come to the next one. Next, applications of the magnets in the daily life. So magnetic garlands. Magnets are used in the decorative displays such as hanging items in a creative way. Okay, so magnetic garlands means you make like this magnetic garlands. Okay, suppose you take bar magnets like this. You take bar magnet. Okay, you take north pole and south pole of the bar magnet. You take some pins. You take some pins. So it will attract like this. It will make like one garland. Like it is making like one garland. And for decorative items, we are using this, right? So magnetic maze. Magnets are used in the games where steel balls are guided through the maze. Already it is there in your textbook. That figure is there like this. Okay, so it has some ways and also where the some gaps are there like this. So they placed in between some magnetic balls, magnetic steel balls like this. Okay, so this is the magnetic steel balls, and these are the this setup we called as a magnetic maze. So these magnets are used in these games where steel balls are guided through a maze. Okay, by using the magnet we can move these steel balls very easily. And lifting steel from the water, a steel paper clip. Okay, already it is there in your book. So when you take one glass of water, you take one glass of water, just you take glass of water and just you drop one pin here. Okay, so let us say this is the pin. This is a pin. Okay, this is a steel pin. Assume that that is a steel pin. Okay, without putting the hand inside the water to lift the pin, we can use a magnet. Okay, so by using this, you take north pole of the magnet here. So north pole of the magnet here, you place here, and just by attracting this, the pin also move with this magnet. And when you leave up to here, so it will come easily. We can take from here. Okay, without putting the hand inside the water to take the pin, we can use the magnet to lift the pin also. Okay, so in this way also we can use. And now a steel paper clip can be lifted from water using a magnet without getting fingers or the magnet wet. So magnetic experiments, magnets can demonstrate how magnetic fields can influence other objects without direct contact. Okay, and we have so many magnetic experiments are there, so let us study about these about in further classes. Okay, now move on to the next one. Okay, keeping magnets safe. To keep magnets safe, store them in pairs with opposite poles facing each other. Now you see, to keep the magnet safe, what you have to do now? So you take two bar magnets, so which is having north pole here and south pole here. You take another bar magnet like this, and here this is having the south pole and the north pole. You place like this. Opposite poles you place like this. Okay, store them in the pairs with opposite poles face with each other like this. And in between, what you have to do? So in between you have to put the one wooden block. Okay, so this is a one wooden block. You have to put like this a wooden block. Afterwards, what you have to do? Place a piece of wood between them and add two soft iron pieces. Okay, you have to add two soft iron pieces. To combine this, you put one iron plate like this. So this is one two. Let us assume this is the iron plate like this. You place one steel soft iron pieces across the ends. You place like this. Okay, and in this way you have to store the magnet. And also, and to keep the magnet safe and you do not get hammering, okay, don't hammer the magnet and don't heat it and don't drop the magnets. Then if you do like this, then what will happen? The magnets can weak the its magnetic strength. Okay, the attracting power or repulsing power of the magnet it can lose. And also remember, always keep the magnets away from the electronic devices to prevent interference. So in this way we can store the magnets. Okay, and this is your lesson. If you like this video, please share this video with your friends, and please don't forget to subscribe. Thank you for watching. Have a nice day. Bye.